Hey guys, this is Algebra 1, Section 2.7, and let's go ahead and get started. Our biblical correlation is this, from Ephesians 6:10 through 18. Finally, be strong in the Lord and in his mighty power. Put on the full armor of God so that you can take your stand against the devil's schemes. We know that in our spiritual life, we've got to have this firm foundation, this full armor, so that we can take on any problem. It's the same in algebra. We've got to have this firm foundation so that we can take on any problem. And we know the reason we need to be able to solve problems is so that we can help bring redemption and restoration to the world around us. Our lesson objective for today is this. You, the student, will solve equations with variables on both sides of the equal sign and translate word sentences into algebraic equations and then solve. If you have an equation with variables on both sides of the equal sign, the addition property of equality is used to move all the variables to one side of the equation. So here's a quick example. Solve 2x plus 5 equals x minus 2. We need to get all the variables on one side and all of the numbers, the non-variables, on the other side. According to the addition property, if we subtract something from one side, then we can also subtract it from the other side, and our equation stays equal. So we want to get rid of the x over here on this side, because we're trying to get just the numbers on this side. And if we subtract x from this side, we've got to do the same thing over here, which leaves us with just one x. 2x minus an x is 1x, plus 5 equals negative 2. Well, now we want to get rid of this positive 5. We're going to use the inverse operation of subtraction to subtract 5 from that side. But whatever we do from one side, we have to do to the other. And when we subtract 5 from both sides, we get x equals negative 7. We can plug that back into our original equation to make sure that it works, and it does. All right, let's take a look at this example. The first thing we see is that we have parentheses. And we know from last lesson that we can get rid of our parentheses by the distributive property. So once we distribute the 3 and the 4, we get 3x minus 12 equals 4x minus 24. We want to move our x's to one side, our x terms, and our number terms to the other side. Typically, I recommend that you choose the side that has the bigger value, and we move to that side. So in this case, the 4x is on the right-hand side, so we can move that 3x over to the right. You could start with the 3x and move the 4. It really doesn't matter. I just like to try and avoid negative numbers if I can. So you'll see that we subtract 3x from the left. That cancels, but whatever we do to the left, we also have to do to the right. 4x minus 3x leaves us with just 1x. Now that we have all of our x's on one side, our x terms, we need to move our constant terms. And the way that we get rid of a negative 24 is the inverse operation of plus 24. Whatever we do to one side, we have to do to the other. And so we end up with 12 equals x, or we can flip that around and say x equals 12. Can we do it differently? Yes, we can. We said we could subtract 4x. And we could go about it that way. But what that's going to do is introduce some negative numbers. Negative x minus 12 equals negative 24. Add 12 to both sides, and we get negative x equals negative 12. Remember that there is a 1 in front of this x, actually a negative 1, so the way that we can get rid of that negative 1 is divide both sides by negative 1. And when we do that, we find out that x equals 12. So you can do it either way. I just like to try to avoid the negative numbers if possible. When solving multi-step equations like the ones that we just did, first we want to simplify both sides by removing any parentheses, using the distributive property, and combining any like terms. So we'll simplify one side at a time. Once both sides are as simple as they can be, then we'll move the variable terms to the desired side of the equation. We do that using inverse operations. We'll also move the number or constant terms to the other side of the equation. We can undo the addition or subtraction of the constant term and undo the multiplication or division that's being done to the variable. Again, using inverse operations. So let's solve 5x plus 3x minus 4 equals x plus 2. The first thing that we want to do is look at each side of the equation and see if we can simplify it. And when we look at the left side, we see that we have two like terms that we can combine. So let's combine those first, and we get 8x minus 4 equals x plus 2. The next thing that we're going to do is move our variables to one side and our constants to the other side. This has the biggest value, 8x, so this is the one I'm going to keep, and I want to remove this one. Well, in order to remove a positive x, I have to subtract it. That would cancel out that x, but what I do to one side, I have to do to the other, so we're going to subtract x from both sides. I now have 7x minus 4 equals 2. But now I want to get the x by itself, so I need to remove this negative 4. The way that I remove a negative 4 is by adding 4. And whatever I do to one side, I have to do to the other. Remember that an equation is two expressions that are equal. In order for things to truly be equal, what I do to one, I have to do to the other. Think about that when you're sharing something with your siblings, when you want an equal share. If your brother or sister gets a cookie, you want a cookie. If they get two, you want two. And if they don't, you say, that's not fair. She got more than me, or he got more than me. It's the same in math with these expressions and equations. Whatever we do to one side, in order to keep that equal statement or that equal sign there, we have to do to the other side so that it stays equal. So we're going to add 4 to the left and add 4 to the right, and that gives us 7x equals 6. Remember, the implied operation here in algebra world is multiplication. So this is 7 times x. In order to undo multiplication, we have to divide. So dividing both sides by 7, because whatever we do to one side, we have to do to the other, gives us x equals 6/7. 7 divided by 7 is just 1. This is 1x equals 6/7. We just don't have to write the 1 because we can see with our eyes there is just 1x. So it's a little redundant to have to write the 1 as well. Again, we're not going to turn this into a decimal or anything else. We're just going to leave it as a fraction. What if you try to solve some equations and there's no solution? It is possible for an equation to have no solution. If there's no value of the variable that makes the equation true, then there is no solution. An equation can also have all real numbers as possible solutions. You don't always have one solution. Think about problems that you try to solve. If we divide you into teams and we give you a STEM activity or some other kind of puzzle to solve, you may come up with different ways to solve it. And each of these ways of solving it is perfectly good. So we can have multiple solutions to an equation. It doesn't always have to equal just one number. Let's take a look at this one. 8 minus x minus 4 equals negative 2 times x minus 6 plus x. The first thing that we want to do is get rid of those parentheses, and we're going to do that with the distributive property. Remember here that this is a negative 1, and we do have to distribute that negative. Okay, over here we distributed the negative 2. Be very careful with your signs when you're distributing negatives because they do change the signs of what they're being distributed to. Now we're going to take a look at each side of the equation and combine like terms. On the left-hand side, we can combine 8 and 4, our two constant terms. And on the right-hand side, we can combine negative 2x and positive x. Negative 2 plus 1 is negative 1. That's where that negative x comes from. Our next step would be to add our integers and put our variables on the other side. But when we do that, something funny happens. We don't even have to do that. We can just stop right here and say, man, these two equations or expressions are exactly the same. It doesn't matter what number I put in here. If I put a 4 here, I have to put a 4 there. It's the same thing. If I put a 5 here and put a 5 here, it's the same thing. No matter what number I put in, all real numbers. If we were to try and solve that for x, what we would get is 0 equals 0. Which is also true. That's an indication that all real numbers is the solution to this problem. This is called an identity. Let's take a look at example 6. First thing we want to do is distribute. See if you can do this one on your own. Pause the video, come back and see how you did. Once we've distributed that 2 and that negative 1 over here, don't forget about that negative 1, we end up with these two expressions. We can simplify our expressions by combining like terms, so we get 2x equals 4x. If we subtract 4x from both sides, what we get is that negative 2x equals 0. You can divide 0 by negative 2. 0 divided into negative 2 groups is just 0. X equals 0. That is a possibility to get x equals 0. Here are some things that we worked on today. Today we solved equations with variables on both sides of the equal sign. We talked about simplifying each side individually by distributing and combining like terms, and then having just variables on one side and just constant terms on the other side to solve for that variable. We also will look at translating word sentences into algebraic equations and solving them when we're in class together. If you guys have any questions, don't forget to ask me next class.